Good evening, ladies and gentlemen. Today, good evening, good sir. Do you need a glass of water or something?
No, but maybe a glass of physics. I kid. Oh, I've forgotten everything about physics, I'm afraid, which is very unfortunate because I teach physics down at the Preugschat Gymnasium.
Wow, I always knew they had teachers.
What?
I said, of course, come in.
All right. You see, I just need to brush up a little bit on my forces, since that's the unit we're starting tomorrow.
First, take one of these. It's called ABCDEFGHIJKL-07. It'll make sure that you won't forget. Now, where do we begin? I'll be teaching you to visualize problems and to solve said problems. First, let me remind you of Newton's 3 laws. Actually, forget the third. These will come in very handy. The first law states that a body will continue to do what it is doing unless if there is an imbalance in forces. The second law of Newton states that force is equal to the mass times the acceleration of an object. Simplified, that is F equals ma.
I remember, yes.
Can you give me those for just a second? Let us create a simple problem first, involving the box of Weet-Bix from earlier, where the forces are balanced. First, we must turn it into a free body diagram. That means that the body is represented by a point. All applied forces are drawn onto it. This point represents the box of Weet-Bix. Since it's standing still, we know that there is a balance in forces. There are no forces in any x direction, however there are 2 in the y direction. They cancel out to 0, since the object is not moving. This is weight and a normal force. Weight is the gravitational field strength times the mass of an object. The mass is measured in kilograms and the weight in newtons. Since we know that the mass is 0.2 kilograms, we can times that by 9.81, which is the gravitational field strength on Earth. However, to make it simpler for this equation, we will just round it up to 10. So the object's mass is 0.2 kilograms and its weight is 2 newtons. Newtons is a measurement of force. Since we know that the resultant force, or the forces added together, are 0, we can find the force of the normal force by this equation. N plus minus W, since one of them has to be in a negative direction, is equal to 0. Since weight is negative 2, N minus 2 equals 0, and N equals 2 newtons. Normal forces are always perpendicular to the surface. Understand?
Yes.
Good. Now...
Oh, I'm terribly sorry. I'm afraid I have Tourette's syndrome.
Alrighty then. Just one more example and we're done. Now let's work on a problem with unbalanced forces. Let's take, for example, a bowling ball. In the exact moment when it is thrown, we know its mass is 5 kilograms and it is thrown with a force of 10 newtons. This is what we call applied force. We also know that it reaches the pins 5 seconds after being thrown, and that the track is 20 meters long. S stands for distance, T for time, and that's all we know for now. Now let's draw up how that looks first. This is the bowling ball. This is the applied force of 10 newtons. There is a weight of 5 kg times 10, which is 50 newtons. And since the ball isn't moving up or down, we know that the normal force is also 50 newtons. What we also know is that there is friction. However, we don't know how much, so that is what we're trying to find out. To find that, we need the acceleration first, because of force equals mass times acceleration. To do that, we have to find the acceleration, which we do by using this formula. Distance is equal to the initial velocity times the time plus half of the acceleration times the square of the time. We have to try to find the acceleration. So first let's replace all the values. 20 equals half of 5 squared times a. We ignore the ut since initial velocity is 0. Then 20 is equal to 12.5 times the acceleration. So then the acceleration is simply 1.6 meters per second squared. Now what we're trying to find is the resultant force of applied and friction, so then we can find the friction force. Since the acceleration is 1.6, we do 1.6 times the mass, which is 5 kilograms, and that is equal to 8. So we know that the resultant force of the x directions is 8. 10 plus negative f is equal to 8. So F is equal to negative 2. So the friction is negative 2 Newton. There, that's simple. I'll take these notes and good luck in class tomorrow. Bye. Ha! I fooled you again. To be honest, all I wanted was one of those A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, 7 pills. They do give me quite a pleasant buzz, I must say. Leave.